Algebra 2, 13.2, Part 2 notes, measuring angles in standard position. So to help us do this, we need to remember the special right triangles. So remember that in a 45, 45, 90 triangle, the legs are equal and the hypotenuse is square root of 2 times each of the legs. In the 30, 60, 90 triangle, the short leg is kind of where you want to start. The hypotenuse is twice as long and the long leg is square root of 3 times as long. So use a reference triangle to find each of the following. All right, what is the sine of 45? So if I start at 45 degrees and I want to do the sine, so that's going to be my n, and actually, you know what? Let's just let n be 1. You could let n be 1, you could let n be 5, whatever you want to let n be, it will work. So if we let n be 1, and then the hypotenuse be square root of 2. Over here, we'll let n be 1 as well. So we have 1, and we have 2, and we have the square root of 3. All right, so sine of 45. So we're going to let the side be opposite, which is 1, over hypotenuse, which is square root of 2. Okay, we can't leave a radical in the denominator, so we need to take this times the square root of 2 over the square root of 2. So we get the square root of 2 over 2. Okay, what is the cosine of 45 degrees? We're going to use that same triangle. Okay, but this time I want the adjacent over the hypotenuse, which is still 1 over the square root of 2, which, if we rationalize our denominator, square root of 2 over 2. Okay, tangent of 45. So the idea is that you can figure this out without having these triangles right in front of you, because you can generate them for each scenario or picture how it's going to work. All right, so tangent 45. So this would be TOA, opposite over adjacent. So tangent of 45 is going to equal 1 over 1, which is just 1. Okay, then we go to our 60 degree, sine of 60. So we have our n, we have our 2n, and we have our n square root of 3. So sine of 60, sine so would be opposite over hypotenuse, square root of 3 over 2. Cosine, if I use that same triangle, is going to be adjacent over hypotenuse, 1 over 2. And then the tangent of 60 is going to be opposite over adjacent, square root of 3 over 1, which is just square root of 3. Okay, we can use the same triangle. I'm going to just draw it a little bit different for the sine of 30. So again, you have your short leg is n, your hypotenuse is twice as long, and the long leg is square root of 3 times as long. So why don't you pause the video and see if you can do number 7, 8, and 9. Okay, number 7 was 1/2. Number 8, square root of 3 over 2. And number 9, don't forget to rationalize the denominator, square root of 3 over 3. All right, next example. Find the measure of each angle in standard position. All right, so what's happening here is we're given a coordinate. We're given the coordinate -2, -2. Okay, and we want to make this an angle, and think of it in standard position like what we talked about yesterday. So we want to know how much degrees this angle is. Well, what we can do is make this right triangle. So we drop the triangle right to the x-axis, and this length was 2, right? It's -2, but the positive length of the triangle is 2, and we went down 2, so that's 2. So this is going to be my n, and n square root of 2. So this is going to be my 45, 45, 90 triangle. Okay, so if I want to know what degree is that angle, and this is 0 degrees, so I'm going to go this way. What I need to do is take that 180 and add to that what I just figured out, the 45 degrees. This will help me figure out what this angle is. So 180 plus 45 would be 225 degrees. Okay, let's try the next one. Now this one's a little bit trickier to draw, but the idea is that you're going negative 2 square root of 3 and up 2. So this length is kind of hard to make it perfect, because what is 2 square root of 3? But we can label it, since we're talking about this triangle here. We're going to make our reference triangle, and that length is 2 square root of 3. This is 2. So this one you would recognize is your 30, 60, 90 triangle, because you've got your n and you've got your n square root of 3. Okay, so what is this angle? Well, the 2 is the short leg. That's across from that smaller angle there. That's across from 30 degrees. The long leg would be across from the 60 degree. Okay, I don't need the 60 degree one. I'm looking for the angle near the origin. So our job was to figure out what is the degree of this angle in standard position. So we want to know what is that degree. So this time, instead of adding it to 180, we're actually going to take 180, because that'd be the whole straight line, and subtract that 30 to get 150 degrees. All right, last one, 0, 1. Where would the point 0, 1 be? 0, 1. Okay, so that's what the angle needs to go through that point. So here's my initial side. That'd be like your 0 degrees, and now it's going to go through this point. So then what is that degree? That would just be 90 degrees. Okay? All right. Your assignment is page 840, numbers 1 through 25 all. Okay, so the first one, you're just trying to figure out what the degree is in standard position. So if we know it goes 45 degrees from 180, we should be able to calculate what it is. Okay, this one, remember for number 2, you always want to bring that angle right up to the x-axis. So it's saying the x value was 1/2 and the y value was square root of 3 over 2. Well, you should be able to recognize that this is that n, and n times the square root of 3. So this is going to be that 30, 60, 90 triangle. Our short leg is 1/2. So there's your 30, there's your 60. So this angle around the origin is going to be 60 degrees. So now if I want to calculate what degree this is, we know that's 180, and then just add that little bit more. Okay, number 3 and 4, you're just kind of sketching them out and then trying to find a coterminal angle. There's a lot of right answers for 3 and 4 for the coterminal angle. Just find one of them. Okay, same thing, some more coterminal angles like we did yesterday. Trying to find what the student did wrong with coterminal angles. And then down here, this is kind of like our notes today. So every time on 7 through 10, you're going to bring that line down to the x-axis, up to the x-axis, up to the x-axis. So always taking it to the x-axis, because that'll show us what that angle around the origin is. down to the x-axis, up to the x-axis. Now number 11 and 8, notice how the angle is going backwards. Remember, that signifies that it's going to be a negative answer. All right, 13 through 25 is just similar to what we did yesterday in our notes. So come on into office hours if you have any questions.